Hello, Professor. My name is Anuj. We are Team 6. For our Senior Capstone Project, we are building a local AI-powered audio transcription and summarization application. Today, we will present our progress so far, explain the technical design, demonstrate our working prototype, and discuss future improvements.
Hello, my name is Huida. Our project is focused on solving an issue that is common in both our academic and professional lives. When we have to manually write down the content of a lecture, meeting, or interviews is a quite time consuming and labor intensive. Even after transcription is done, reviewing the content over of the recording is not very efficient either. And most of tools on the market use cloud-based technology to operate, which means the audio content is stored on the cloud server. This is not exactly the most private and secure way to handle our information.
Hi, my name is Sal Patel, and for this slide, I'm going to explain the overall workflow of our system from start to finish. First, the user uploads an audio file into the web application. This could be a lecture, a meeting, or interview recordings. The system then processes the audio locally to prepare it for transcription. This pre-processing step ensures the audio format is compatible and optimized for accurate speech recognition. After that, the audio is sent to a speech to text API, which converts the spoken content into a full transcript. Over the transcript, once the transcript is generated, it is passed into a summarization model that analyzes the text and produces a concise summary highlighting the key points. Finally, the transcript and summary are stored locally within the application session so users can review, edit, and export the results. The overall goal of this workflow is to make transforming audio into structured information fast and privacy conscious.
Hello, this is Zach Ganser, and I'm going to be talking about the technical architecture we're using for our project.
We have successfully implemented a working prototype. The system can ingest an audio file, generate a transcript, and produce a summary. The current interface is basic but functional, and we have export options for transcripts and summaries. This framework allows us to build additional features on top of a stable foundation.
Okay, so this is Zach Ganser again. I'm going to be running you through our project demonstration. So what we have so far. So here we got a repository open. Obviously, when we package this, bundle it for users, all our assets will be packaged and bundled with it, so the end users don't have to worry about pulling any of these assets or dependencies. But for right now, they're just kind of sitting as part of our repo. So we obviously have our FFmpeg. We need those to kind of massage and kind of convert and get the audio files exactly the way our Whisper model wants it, for fast, efficient um, recording or transcriptions. We also have in here, we have all of our llama files we need that'll hook into our Mistral summarization model, which is sitting right here. And then for Whisper, for our faster Whisper, we're using a small model to start. This is a locally stored and locally run app, so we want to keep it kind of as lightweight as we can. Um, so we're starting with a small, and the transcription's been honestly been fine for that right now. But one of the things we have in the pipeline is allowing users to, if they're willing to give us some extra storage space and some more compute power, downloading more robust models like say like the Whisper Media model. So get this app going right now. So this is kind of our um, prototype initial build of this app. Um, I'm not a front end guy, so it's pretty bare bones to look at. One of the things we'll be doing as the semester goes on is kind of updating that GUI, make it a little more sleek, a little more pretty looking for the end users. But this does just fine for right now for our building and testing. So right now we have it set. You can pick any audio file you want. So I'm just going to pick one that we have. I just have lying around here. Doesn't matter the format on the back end or FFmpeg. We'll just convert it, get it however we want. So we're going to see we have a little progress bar here. Is just so the user doesn't think they're just kind of stalling out. So we're going to start with transcribing the audio file. This is about a 10-minute file. Typically, this is taking about a minute to transcribe. But we're always looking for improvements where we can, either with the model or with the back end code, or eventually in the pipeline we have the app can like if you have an NVIDIA GPU, run it with the CUDA instead of on the CPU. That's a performance boost with the Mac OS running it through the silicone chips. That's it's a performance boost over running through the CPU. But for right now, the CPU is the easiest to get going, so that's what we have. So now we're going to be breaking the transcript down into chunks. We're doing this for a couple of reasons. One, if we just feed one large transcript file into the summarization model, it's not going to be very, it's going to go slow trying to coalesce all that information at once. And also, it could lead to issues where the model starts to lose a little context for what are the important things to summarize here from this whole transcript. So we're going to chunk it and then send each chunk into the summarization model. And what we're going to do is the model is going to come up with 5 to 7 bullet points for each chunk. And then it's going to flatten those chunks down into a JSON file. We tried to regex at first, but it doesn't play nice with our summarization model, Mistral model in Llama. So we went to a JSON file to do this. It's ended up being elegant. Now we are running into a few issues. Sometimes the summary will go off without a hitch. Sometimes the JSON file will be a bit malformed, and we'll get an error. If that happens, I've got an image of a run I did a little bit ago. So that's just something we're working on and iterating through. Most of the time, it runs without a hitch. But yeah, so we want to flatten, like I said, flatten all the summarizations. I'll pull up the run from earlier. We're going to flatten all the summarizations into a JSON file to feed back into the summarization model one more time. It's going to take all of those bullet points and it's going to build the summary from the whole transcript from that. So you can see here for the transcript, we have timestamps. They're just by seconds right now. One of the things in the pipeline is getting that converted to minutes and seconds, just to make it easier on the end user to see exactly what's going on. And you'll see right now, since we are feeding into the model by character, the output isn't super pretty. It's a little messy. Thoughts, sentences, kind of get broken up here and there. It makes it a little a little more difficult to read, a little harder to parse. So that's one of the things we're working on down the pipeline is kind of making this transcript a little better to look at, a little easier to look at. But this is just the initial build. Um, so we're always iterating from here. On the summary pane, you can see, so right now for debugging, we're actually listing the chunk outputs for what the model determined the most important bullet points to summarize for each chunk. This way we can compare it against the transcript, make sure it's kind of lining up how it wants, so we can continue tuning. The other thing is at the top, you'll see the actual summary. When we flatten the chunk output into a JSON file, um, we'll get the full summary for the whole transcript, and then a 1 to 2 paragraph kind of description, just kind of outlining the general summary of the transcript. You can also see down here we have an export transcript and summary, so the users can export those as text files, so they're not just housed in the app. So that's what we have right now, but we got more in the pipeline. But I think this is a great start. And yeah, that's our project demonstration.
This is Sahil, and this slide outlines improvements and enhancements we plan to implement as we continue developing the system. First, we want to improve the user interface design and formatting to enhance readability and make navigation more intuitive. A cleaner layout will improve accessibility and overall user experience. We also plan to convert transcript timestamps into a minute to second format. This just makes the transcript easier to follow and allows users to quickly reference specific parts of the audio. Another important enhancement is implementing SQLite based history storage. This would allow users to securely save and revisit previous transcripts and summaries instead of losing them after each session. We also aim to optimize model performance by reducing processing time and improving summary accuracy, ensuring the system remains efficient even with longer audio files. Finally, we plan to package the application into a standalone installer so it can be developed more easily and potentially used outside of a development environment. These improvements help move the system from a prototype toward a more production-ready application.
I am Hoida. In conclusion, we have managed to create a working version of our local AI tools that is able to transcript and summarize audio content. The tool is able to read the audio content and create a summary of the content in the most concise way possible. The beauty of our project is the fact that is private and the information is not shared with any server. We now have a strong foundation and will continue improving the interface, optimizing performance, and packaging the system for easy distribution.